In this video, we are going to discuss one of the colligative properties, osmotic pressure. Colligative properties depend on the number of solute particles dissolved in solution, not on the type of solute particle dissolved. In other words, these properties are dependent on concentration, but not on the identity of the solute. Nature's tendency to mix leads to the process of osmosis. Osmosis is the phenomenon where water will flow to the area of higher solute concentration. For example, in the cell shown, a solution containing some concentration of solute is separated from a pure solvent with a semi-permeable membrane. This membrane, similar to the membranes that protect the cells in our body, is selective for the substances that are allowed to pass through it. In this case, the solute on the left side of the semi-permeable membrane is not permitted to pass. Therefore, in an attempt to equilibrate the concentrations of the solutions on both sides of the membrane, the pure solvent on the right side of the membrane will flow to the left, therefore diluting the left solution and causing the solutions to be more similar. This leads to a raise in the solution volume on the left side of the membrane and a decrease in the volume of pure water on the right. The pressure that must be applied to the left cell in order to stop the flow of the solvent from the right, aka the osmotic flow, is defined as osmotic pressure. The osmotic pressure can be quantified using the expression pi equals mRT, where pi is the osmotic pressure, m is the molarity of the solution, R is the ideal gas law constant, 0.08206 liters times atmospheres per mole times Kelvin, and T is the temperature in Kelvin. In situations where the solute is an electrolyte, we will include I, the Van Hoff factor. We can see from this expression why the osmotic pressure is a colligative property. It is dependent on the number of particles in solution, expressed by the molarity and the I value, but it is not dependent on the identity of the particle. Plugging in the values for each variable with the correct units, we can visualize the units cancel and calculate the osmotic pressure in the units of atmospheres. In this problem, we are asked to calculate the osmotic pressure of a solution containing 1.50 grams of ethylene glycol in 50 milliliters of solution at 25 degrees Celsius. In order to calculate the osmotic pressure, we need to know the molarity of the solution and the temperature of the solution. The variable R is the ideal gas law constant and is equal to 0.08206 liters times atmosphere per mole times Kelvin. We are given the temperature of 25 degrees Celsius, but as we have discussed, in order for units to properly cancel, we must convert the temperature to Kelvin. You may recall that adding 273.15 to a temperature in degrees Celsius will convert the temperature to Kelvin. Therefore, the temperature in Kelvin is 298.15. We are not provided the molarity in the problem. Therefore, we must use the information given to calculate the concentration. We know that 1.50 grams of ethylene glycol is dissolved in 50 milliliters of solution. With this information, we can calculate the molarity. Recall that molarity has the units of moles of solute per liters of solution. We can first find each of these entities separately. Like we said, we know that we have 1.5 grams of solute ethylene glycol dissolved in solution. From this information, we can calculate the moles of solute. If we calculate the molar mass, which has the units of grams per mole, we can use this value as a conversion factor. Using the chemical formula of the molecule and the molar masses on the periodic table for carbon, hydrogen, and oxygen, it can be determined that the molar mass of ethylene glycol is 62.07 grams per mole. Dividing by this value allows for the units of grams to cancel, providing us with the information that 0.0242 moles of ethylene glycol are in solution. We also know that there are 50 milliliters of solution. In order to calculate the liters of solution, we simply use the conversion factor that there are 1,000 milliliters in 1 liter. Therefore, there are 0.0500 liters of solution. Using these two values as the numerator and denominator to make up the components of molarity, the concentration is determined to be 0.483 molar. Now we can calculate the osmotic pressure. Plugging in the values for molarity, temperature, and the ideal gas law constant, the osmotic pressure is calculated to be 11.8 atmospheres. Overall, in this video, we have defined the colligative property known as osmotic pressure.